And debate scientist, this hydrogen chloride directly prepared, direct combination of hydrogen and chlorine gas. Mr. Glover scientist, it is prepared by using salts of sodium reacted with the concentrated sulfuric acid on heating. It gives sodium hydrogen sulfate plus hydrochloric acid. Yes. Okay. Then again this sodium hydrogen sulfate react with NaCl. It gives Na2SO4 plus HCl hydrochloric acid. This is the sodium hydrogen sulfate, that is bisulfate. Na plus 1, this is minus 1. Sodium hydrogen sulfate, or sodium hydrogen is the bisulfate. This is a plus 1 into 2 plus 2, this is the minus 2, just sodium sulfate. By Glover's scientist. Glover scientist prepared this. Mr. Device scientist prepared this hydrochloric acid direct combination. Direct combination of hydrogen and chlorine. Now, here the hydrogen is reacted with chlorine. In the presence of dark, it is not a slow reaction, but it is carried out in sunlight, UV light. So, in the presence of sunlight, it gives hydrogen chloride, HCl. Now, the obtained hydrogen chloride in gaseous state, we can condense into liquid and also condense into solids based on their temperatures. It is a colorless initially gas and converted to liquid. Now, this hydrogen chloride is a colorless gas that can be converted into a liquid. For that BP boiling point is 189 kelvins, and it is freezes as a solid white crystalline substance. Freezing point is 159 kelvins. Okay, boiling and freezing points of that hydrogen chloride. Now here chemical properties of HCl, chemical properties of hydrogen chloride. Your HCl is readily soluble in water, and it gives here the H3O plus Cl minus solubility. Now this is called your aqueous hydrogen chloride. Aqueous hydrogen chloride is now it is called hydrochloric acid. The difference between hydrogen chloride and hydrochloric acid. So when HCl is dissolved in water, it produces like H plus aqueous and here H2O aqueous and here the Cl minus aqueous, that is hydrochloric acid. Pure HCl is called a hydrogen chloride. So this hydrochloric acid easily dissociate in water. It gives an aqueous medium, it gives H plus Cl minus aqueous medium. Now its constant, dissociation constant is 10 power 7. Due to the high dissociation constant, it acts as a strong acid because hydrochloric acid has a more high dissociation constant, that is Ka, dissociation constant of acid. Its value is more, that's why it is a strong acid. It is a monobasic acid because it produces only one H plus. It is a monobasic acid. Okay. Now next property of hydrochloric acid is reacts with the ammonia. Very important reaction this is. This reaction already given in IIT examination, that is JEE examination, simple question created based on this. When hydrochloric acid is reacted with ammonia gas, it forms corresponding salts of ammonia. Ammonium chloride is formed. That is with ammonia and H3. Now here the HCl is in gaseous state, reacts with ammonia gas, NH3 gas, then it forms ammonium chloride, NH4Cl. Okay, ammonium chloride is formed. One year asked based on this on a simple question. This is one copper tube like this. This copper tube is connected two leads like two leads. Through this two leads, through one lead first you have hydrochloric acid, through the another inlet ammonia gas is passed. This white dense fumes of ammonium chloride gases are formed nearby hydrogen chloride edges or nearby ammonia gas edges, where it forms nearly ammonium chloride. Means here the hydrogen chloride and ammonia react with each other, it forms ammonium chloride, no doubt. But question created like in IIT, creativity question. That is here hydrogen molecular mass is 1, chlorine is 35.5, total 36.5 grams molecular mass, this vapor. But its weight is ammonia is 14 plus 3, 17 grams. Which gas molecular mass is generally more? Here hydrogen chloride gas mass is more. Mass is generally more. Then density is generally more, and volatile nature is less than compared to that ammonia. So this is readily vaporizes and move very fast and comes nearer to the hydrochloric acid. Now with speed, with certain speed, easily vaporizes because its molecular mass is less. Then NH3 is nearly HCl gas, react with each other, it forms ammonium chloride, nearby hydrogen chloride ends. This is the answer. Very important reaction this is. So after this, one of the most important use of HCl, it is acts as a strong acid. Due to this strong acidic nature, this is used as a solvent. This is used as a solvent under the name of aqua regia, that is 1:3 ratio. Concentrated HNO3 plus concentrated HCl is called a aqua regia. So one ratio is HNO3 and 3 ratios are concentrated HCl. So in examination, to confuse the children, they'll give 3:1 also. They'll give the 1:1 also. They'll give the 3:3 also. They'll give 1:3 also. 4 options. That is one objective question. This is the option number 1, 2, 3, 4. Aquaresia combination is 3:3 ratio, 1:1 ratio, 3:1, 1:3. These two are correct. These two are correct, but depending upon the representation. First, if they'll give concentrated HCl first, then concentrated HNO3 is there, now it is correct. Because 3 moles of HCl and 1 mole of HNO3 correct. Here they'll give the concentrated HCl plus concentrated HNO3, not 1 mole, 3 mole. That's why it is wrong. These 3 are wrong. This is the correct one. So this aquaresia is used to dissolve some noble metals. To dissolve noble metals means like gold and platinum metals. Gold and platinum metals are dissolved in aquaresia because these metals are not easily affected by some acids. So due to this reason, dissolving nature of these two compositions, HNO3 and HCl, all the students, while doing some experiments in the laboratory, be careful and take precautions. Don't wear any gold rings or the chains, because unfortunately, along with HCl, your HNO3 is added. Your HNO3 and HCl maybe combinations, maybe ratios increases, then it produces some vapors. These vapors are immediate in contact with the gold or the platinum rings or the chains or the bracelets, easy to decolorizes. Gold dissolves. So generally, while doing the test like this, by using a test tube like this, while adding like HCl and HNO3, if you can use like gold ring vapors produce and in contact with this like gold rings, then decolorize, gold dissolves in that. That's why it reduces the gold strength. That's why while doing any experiments in the laboratory as a scientist, no need to wear any gold rings or the bracelets. Or as a science student in the laboratory, you laboratory don't wear like rings or the chains. Be careful. So anyhow, here the gold or platinum, both are readily dissolved in this combination aquaresia. It gives corresponding salts. How it dissolves? I'll give two important reactions. Just note down, ionic reaction I'll give. Now here the gold AU reacts with 4H plus NO3 minus 1 plus 4Cl minus. This is the combination of aquaresia. We can use here related to balance that, we can use like a number of moles of H plus and Cl minus and NO3. In acidic medium, 1 mole of H plus is more than compared to that NO3 minus 1. Both are acids. That gives corresponding AuCl4 minus 1. It is one complex ion. Tetrachloroarate complex. Plus here the NO, nitric oxide gas, plus reddish brown vapors are produced, plus colorless gas is produced, plus here water is formed, like 2H2O water is formed. Now it is balanced. Now this is solid gold is dissolved in this aquaresia. Then it forms a pure gold, solid state gold is readily dissolved in this, it forms corresponding salts. Similarly, platinum, 3 moles react with 16H plus your NO3 minus 1 plus, now here 18Cl minus, it gives platinum Cl6 power minus 1, here the 3 moles. 3 6 is 18, that's why 18Cl balance. And here the 16H plus and platinum required, here NO gas is produced. NO plus your 8 H2O water is formed because of 16 H plus. Now here 8 oxygen atom, this is the 9. Totally here 3 are there, 9 we want here. So here the corresponding nitrogen atoms, if we can take, here the 16. Here nitrogen gas and here water as it is. Now it is platinum hexachloride is formed. Now this pure platinum is readily soluble in corresponding aqua regia. This is okay. Now after this solubility in water as well as in aqua regia conditions, noble metals are readily dissolved in aqua regia, that is 1:3 ratio HNO3 and HCl. Next important one is here HCl decomposes weaker salts. Weaker salts are the weaker salts of acids against corresponding gases, corresponding related salts like carbonates, bicarbonate, and sulfides decomposes easily as corresponding gases. Like carbonates means I'll take Na2CO3 is reacted with hydrochloric acid. It decomposes against 2 NaCl sodium chloride plus H2O plus carbon dioxide gas is liberated. Then here NaHCO3 bicarbonate, this is with hydrochloric acid against NaCl plus H2O plus carbon dioxide gas is liberated. Here the sodium sulfite Na2SO3 plus 2HCl against your 2 NaCl plus H2O plus SO2 gas is liberated. Corresponding gases these are. So very important reactions. HCl decomposes weaker salts of acids or the salts of weak acids. Then one of the most important reaction is your important reaction for objective. It dissolves when it dissolved in iron, like iron is reacted with concentrated HCl, it gives corresponding FeCl2 plus hydrogen gas is liberated. Now here take 2 moles, it gives FeCl2 plus hydrogen gas. Now here Fe plus 2 is there, here 0 is there, here to here positive charge increases. Here removal of electrons takes place, oxidation reaction takes place. Here it is plus 1 and it is 0. Here to here reduction reaction takes place, reduction, addition of electrons. Okay, it is a redox reaction. But here main question is, main important concept is the obtained FeCl2 do not convert into FeCl3. Do not convert it into FeCl3 means here Fe reacts with like 6HCl or 3HCl, like here it gives FeCl3 plus 3 moles of H plus. Do not takes place this reaction because the formed H2 gas prevent the prevent the formation of FeCl3 from FeCl2. Very, very important this is. Based on their standard reduction potential values, SRP values, based on their reactivities, why hydrochloric acid react with Fe of iron, it do not converted into FeCl3, it gives only FeCl2. Why? Give reason. Reason is this: the obtained gas, hydrogen gas, prevent the formation of FeCl3 from FeCl2 based on their SRP values, because for hydrogen standard reduction potential value is 0.00 volts. So based on this, there is an important part in electrochemistry. There will explain their reactivities, which one is readily replaces some gases from their corresponding acids and metallic salts. Okay. These are some important preparation methods and properties of hydrogen chloride. The next one is very simple uses are there. Uses of HCl, hydrochloric acid. Uses of HCl. Now it is used in the production of production of Cl2 gas as well as ammonium chloride NH4Cl. So main production of Cl2 and ammonium chloride. So it is used to dissolve noble metals. Noble metals means like gold and platinum. Just explain. And it is used as a laboratory reagent. Laboratory reagent. So many organic and inorganic reactions are treated with hydrochloric acid, and so many uses are there. Better read remaining uses from textbook. Okay. So these are the some important points about hydrogen chloride. Next last but one concept is Oxo acids of halogens. Heading. Oxo acids of halogens. So are the halogens means we know are fluorine, chlorine, bromine, iodine. Astatine is a radioactive element. So among these, fluorine is more electronegativity element. Now here F is more electronegative element and small in atomic size. Small in atomic size it is. So due to small in atomic size and more electronegativity, fluorine form only one oxo acid. That oxo acid is HOEF. This is very, very important. Only one. That oxo acid is generally it is called hypochlorous acid. It is, or simply it is called halic 1 acid. Halic 1 is nothing but oxidation state of this is like -1. This is the +1. This is the oxygen also. Here it indicates -2. Compulsory here +1. But this fluorine do not show +1. In this case, here minus. Now here it exhibit minus. Now here oxygen is +2. Oxygen exhibit +2 oxidation state. Now here the halic acid 1. Now this is called fluoric 1 acid. Now here the halic is nothing but fluoric. If it is chlorine, chloric. If it is bromine, bromic. If it is iodine, iodic. Or it is commonly termed as hypohalous acids. These are denoted as HOX. Hypohalous acids. Remaining chlorine, bromine and iodine forms are the many oxo acids. These many oxo acids are not stable and are not isolated in pure state. So many oxo acids are there. All oxo acids are not stable. They are not isolated in pure state, but they are isolated and these are stable. These are stable in salts of oxo acid nature, oxo acid form. That is in ionic state, in soluble state, they are very stable. In pure form, we can't isolate. Like your chlorine, bromine and iodine forms like your HOX, your HOXO, your HOXO2, your HOXO3 are formed. These are some important oxo acids of chlorine, bromine and iodine. So among these some important examples created under the name of an important table. I'll create a table, just note on the table. For fluorine, chlorine, bromine and iodine, create an important table. Okay, first one is hypohalous acid. This is called a halic 1 acid, first one. Then second one is here second one is halous acid, that is also called halic 3 acid 1,3. This is second one. Third one is your halic acid, also simply it is called halic 5 acid. Now here the fourth type is here perhalic acid. This is also called halic 7 acid. This is one important table created. So the first one is for fluorine. Your fluorine, now your chlorine, and it is for bromine and iodine. Now here four important acids. First one is it forms only, that is HOF it is. Remaining are not formed. This is generally hypofluorous acid it is. Hypo common, halous means if it is fluorine, Fluorous acid. For chlorine it forms HOCl. This is the hypochlorous acid. Here the HOClO. Here halus means chlorous acid. Now here the HOClO2. This is halic means here chloric acid. Now here the HOClO3. This is perchloric acid. Halic is nothing but chloric, bromic like. Now here these are generally do not forms like halus. Now these three are formed like HOBRO. This is your HOBRO2, your HOBRO3 like this. Here also your HOIO, HOIO2, HOIO3. This we can take as HiO4. Yeah, it is HiO3. This is HiO2 like also we can take. Now name is for this just like chlorous, it is a bromous acid. It is bromic acid. It is perbromic acid. Same thing here, iodous acid, iodic acid, periodic acid. These are the some important oxo acids of halogens. So particularly your oxo acids of chlorine are very, very important. A formula is HOX like model. It is HOXO like it is. A formula is HOXO2 like this. This is HOXO3 model. Chlorine oxo acids are very, very important. Clear? So based on this, we'll create some important structures. Guarantee they'll ask one question based on this. If they'll ask anyone better, either fluorine or bromine, these four are very, very important. So among these chlorine oxo acid, its acidic strength is, for chlorine acidic strength is, for this, here the HOCl is less than, HOClO is less than, HOClO2 is less than, your HOClO3. Perchloric acid is more acidic nature. This is acidic nature of corresponding oxo acids of chlorine. Very, very important this is. Okay? Noted? Among all these, your more acidic nature oxo acid is this perchloric acid. So its acidic strength of corresponding oxo acids of chlorine order is oxo acids of chlorine. Here four are available. Its acidic nature order is, this is HClO we can take. Here the HClO2 we can take, HClO3 we can take, and HClO4, this is perchloric acid, that is more acidic in nature. Now regularly your first one is we can take HOCl. It is pure form, pure nature. And pure state, it is unstable. Unstable it is. So it dissociate, it gives H plus ClO minus. Now this is stable ion. This is stable ion. Means in pure state, HOCl in pure state, it is not a stable, it is unstable, easy to dissociate, it gives H plus ion. That's why anything it produces H plus ion when dissolved in water are easy to dissociate. That's why that is acidic in nature, it gives ClO minus 1. Now that ion is a stable ion. This ion is called a, generally this is acid. HClO is acid, hypochlorous acid. Now this is called a hypochlorite, ITE. For us we will get ITE, for ic we will get ATE. So any us acids are there, OUS acids are there. For us acids we will get ITE. ITE salts. ITE salts. Now, for example, here the H plus is there. Instead of this H plus, we can take Na plus ClO if we can take. This is minus, or also we can take NaOCl. This is called a sodium hypochlorite. Sodium hypochlorite it is. Very, very important. Now here the HOCl is unstable, pure state. When it is reacted with certain salts, gives corresponding stable salts, stable ion, that is ClO minus 1. It is a stable ion. That's why your HOCl acts as an oxidizing agent. Oxidizing agent because it is unstable, ready to produce nascent oxygen. Because HOCl ionizes, it gives HCl plus nascent oxygen atom produces. Unstable, acts as an oxidizing as well as a bleaching agent, but its ion is stable like NaClO or NOCl, sodium hypochlorite. If it is potassium, KOCl, potassium hypochlorite, this is as it is potassium hypochlorite. Here the rubidium hypochlorite, this is rubidium hypochlorite. Now by using this simple analysis is about this HOCl, in a pure state it is unstable, but it is in a salts form, ions are stable. Such a ions, hypochlorous, this is the name is, its name is hypochlorous. This hypochlorous acid gives salts of halides, salts of hypohalides. Hypohalite, this is. See here? This HOCl, hypohalous, gives salts of hypohalite. See here? Sodium hypohalite, sodium hypochlorite. Clear? Now, by using this in examination, they'll ask its a structure. Now, here oxygen containing 6 valency electrons. Now, out of 6, one is reacted with the hydrogen, another one is reacted with the chlorine, like this. Generally, it is considered as slightly linear or bent like a structure, this is. Now, here in this case, here oxygen and chlorine, and these are satisfies 8 electrons, but it satisfies the 2 electrons, duplet electronic configuration. Structure of this HOCl. Yeah, between oxygen and chlorine only one sigma bond is there. Lone pairs are 3 lone pairs are there. If they will ask, its hybridization is sp3. Why it is sp3? One sigma bond and 3 lone pairs are there. Hybrid orbitals are Lp plus Bp. Under this Lp are 3, Bp is 1, that's why 4, that's why 1 s orbital and 3 p orbital. That's why its hybridization is sp3, but not a tetrahedral between these. Yeah, lone pair repulsive forces are there. We can take between these, it is linear. Yeah, we can take as an angular shape like. Okay, this is a story about first one, HOCl. Similarly, HOClO like HClO2. This HClO2 is called, this is hypochlorous. It is called a chlorous acid. This chlorous acid gives salts of chlorides, salts of halides. There is no hypo word here, just halide. For hypochlorous, hypohalide. For chlorous acid, simply salts of halides only. That's why next important concept is compound is oxo acids of chlorine. Next one is second one is HClO2. This we can write here the HOClO. This is. Now for this we can take as its ionized nature. It gives here the H plus plus here the ClO2 minus 1. This is unstable, but is a stable ion it is. This ion is called a chlorite ion it is. It combines with sodium like NaClO2 or KClO2. It is called a sodium, don't use hypo. Sodium chlorite it is. It is a potassium chlorite like this is. Because OUS is there, US is there, US is there, US acids gives ITE. Sodium potassium chlorite. Instead of hydrogen, we can take Na or sodium alkali metals. It gives corresponding salts. They are the halides. They are the chlorite, bromite. Also, we can take like NaBrO2 or NaIO2, sodium bromite, sodium iodide. Similarly, by using this for this one structure is here two oxygen atoms, one chlorine and this. Now here chlorine is considered as a central element. On this chlorine, 7 valency electrons are there out of 7. One lone pair is bonded with one oxygen. And one unpaired is there, that unpaired is reacted with this OH group like, clear. And remaining here 2 lone pairs are there. This is a lone pair and this is a lone pair like this. And our textbook not given like, remember like. Now here around the sigma bonds are 1, 2 and these 2 are the LP electrons, lone pair. That's why our hybridization is, it undergoes sp3 hybridization. Because hybrid orbitals are Lp plus Bp. Now Lp2 and Bp2, that's why 4. 4 means 1 s orbital and 3 p orbitals. Here pi bonds are 1 pi bond and sigma bonds are 2 are there. 2 sigma bonds and 1 pi bond is present. To get this pi bond, compulsory on a d orbital required. In chlorine, d orbitals are there. That's why that pi bond is p pi and d pi bond it is. Okay. Here one pair donated to this, it forms a coordinate covalent bond. Sorry, one pi bond. Here one unpaired electron is there, which is bonded with oxygen atom. Here on oxygen atom, again it contains two lone pairs. This is the structure of and hybridization of this HClO2 chlorous acids. These remaining two are the chloric acids. This is the chloric and perchloric, both are ic only. So for ic acids, we'll get instead of ITE, ATE, chlorates, bromates, iodates. So next one is, next important compound is oxo acids of chlorine compound is. Third one is, third important compound, this is, it is a chloric acid, that is under the name of halic acid. This is, we can take as 5 indicates oxidation state, halic acid. Now here oxygen is -2 into 3 minus 6, hydrogen is +1, compulsory chlorine is +5. That's why in Roman number we can write. Here it is called a perchloric acid. This is called a perhalic acid. That is perhalic 7 acid is the oxidation state of chlorine. Because chlorine oxidation state. Here it is oxygen is -2, chlorine is compulsory to satisfy the 8. Here +1, chlorine is +7 oxidation state. So here in third case, HClO3 ionize, it gives H plus ClO3 -1. This ion is a stable ion generally. Now this stable ion is called your chlorite ion it is. Now instead of this hydrogen atom, we can take NaClO3, your NaBrO3, your NaIO3, this is. It is called sodium chlorate. Now here it is sodium bromate. It is sodium iodate. Now in surface chemistry and in P block elements only, one question given to you, that is KClO3 on heating with manganese dioxide MnO2 on heating, here are 2 moles, it gives 2 KCl plus 3 O2. Very important reaction given, where in the preparation of dioxygen in S block, in P block elements, 16th group elements, oxygen formally, preparation of dioxygen by the thermal decomposition of what is the name? Potassium, KClO3 like NClO3, potassium chlorate. So instead of NaClO3 sodium chlorate, it is a potassium chlorate. On thermal decomposition, it gives 2 KCl plus dioxide is obtained. Very important reaction for this. Now here structure is, around chlorine 7 valence electrons are there. Out of 7, 2 are like oxygen double bonds, like one is with oxygen and hydrogen. Now here 2 electrons, 2 like 5, and 1 electron pair is there. This is sigma bonds are 1, 2, 3 sigma bonds. Remaining 2 are the pi bonds. Now here are 2 pi bonds. Here 2 pi bonds are present. Sigma bonds, how many are there here? 3 sigma bonds, and lone pair LP is equals to 1. Now here the sigma 3 and 1 lone pair, that's why this chlorine atom undergoes a sp3 hybridization. Now just like it is NH3 like structure. So 3 sigma bonds and 1 lone pair, due to the presence of this lone pair and bond pair repulsive forces. Even though it shows sp3, it has pyramidal structure, pyramidal geometry. This structure and hybridization and different types of salts of corresponding chlorous or halous acids. Next one is perchloric acid. Sir, last fourth one is HClO4. This HClO4 ionize, it gives H plus ClO4 minus 1 it is. So this ion is called a perchlorate. This is perhalorate. Halorate, this is salt. This is obtained from perhaloic acid. Perhaloic acid means your chlorine is used, that is perchloric acid. This perchloric acid formula is ionizes. Instead of this hydrogen ion, if you can take NaClO4 or the KClO4 or RbClO4. Instead of this, we can take KbRO4, this is, or KiO4 like, or sodium combination, we can take NaBrO4, like NaIO4 it is. What is the name of this? Sodium perchlorate. Because here IC is there, ic is converted into ATE, chlorate. S is converted into ITE. That's why sodium perchlorate, potassium perbromate, sodium perbromate, potassium perchlorate, potassium periodate, sodium periodate, rubidium perchlorate. Names are very, very important. Then finally, its structure, last. Last, in this perchloric acid, here 4 oxygen atoms are there. We can take here Cl, central atom of an element, like oxygen atom, here oxygen atom, and here oxygen atom. Take here like this is hydrogen. Now here sigma, here sigma, here sigma. Pi bonds are 3 pi bonds are there. Now this chlorine undergoes sp3 hybridization because sigma, sigma and sigma, 4 sigma bonds are there, like 1, 2, 3, 4 sigma bonds. There is no lone pairs. That's why it undergoes here sp3 means tetrahedral. So why it undergoes a tetrahedral structure means there is no lone pair bond pair repulsions. Only here bond pair and bond pair electron pair repulsions are there. That's why geometry is tetrahedral and sp3 hybridization takes place. Here sigma bonds, 4 sigma bonds are there and 3 pi bonds are there. Now this OH group 1 is there, that's why ready to replace this. This is also a monobasic acid. Basicity is equals to 1. This is the highest, strongest oxo acids of chlorine. Order already given. So these are some important points about oxo acids of halogens. Among all halogens, chlorine is the most important. That's why 4 important oxo acids explained. That is perchloric acid, chloric acid, chlorous acid, hypochlorous. Here are 4 important. HClO4 highest. Here HClO3. Here HClO2. Then HClO. These are. Okay. Remaining only one simple important concept is there. That is interhalogen compounds.